Here Nathan from Group 49. Our project is a self-driving wheelchair for inclusive mobility at Makerere University. But now we named it the Mac Auto Wheel, and the targeted customers are persons with physical disabilities, universities and hospitals in Uganda. Here we have a YOLO, working YOLO object detection model deployed. Here you can come and see how it is working from there. We are not going to demonstrate due to time. The problem space and purpose. The core problem is mobility exclusion. Here we know that the persons with disabilities at Makerere University face dependence, 30 to 60 minutes delays waiting for escort, and also discomfort in crowded campuses. Now, who experience it most? Obviously, the student and staff with physical disabilities, caregivers, escorts, and university administration. Why AI and not mere automation to do this? Why AI? It is on perception, identifying objects like people, chair, and trees, and so on. Reasoning, making real-time navigation and decisions to where you are going, where you are from, and so on. And adoption, learning and improve in new environments. Major impact. In social, we expect to do independence of persons with disability for over 10,000 people. Now, in economic is to reduce caregiver cost by 80% because it will be just moving autonomously. Behavior, it is better class attendance and participation. If someone is having wheelchair more, just will even be eager to walk directly. Here you have the user and stakeholder. You have the primary user. Those are the direct users, where you have the students and staff using the autonomous wheelchair, and also wheelchair hospital patients. We also have the secondary user, or we call them the stakeholders, where we have the university hospital management. University or hospital management, we have the disability right organization, caregivers, then the broader campus community. We also have the ecosystem role, where we have here the data suppliers, that is the Makerere University, campus map, navigation data, where we talk, and also API customer, that the algorithm designers, and that will be on us, the engineering team and AI development team. Now, the platform maintainers, we have the project team, us, plus the university information technology department. Now, the governance ethics, we have those ensuring ethical compliance and technical reliabilities. That is in Makerere University research and ethics community. Have engineering team. We have the Uganda National Bureau of Standards in case of future certification. We have the data sources and the data sources. We have the data type, where we got the RGB images. We have depth data, that's in the distance. We have LiDAR, point cloud, and we have ultrasonic sensor readings. Sources, proprietary, we have the videos and sensor data from Makerere University, which we've been taking, and also the RoboFlow available data set. Also, we have the public RGB, that's the RoboFlow, that the pre-trained data set, and also the synthetic, we have the generative attention network, or the GANs, and also the relational attention network, which is generating images for crowded hall in order to simulate them with the real one to get the accuracy, maximizing accuracy. Processing pipeline, have collection of data, cleaning and synchronization. We have annotating them, also validating, and finally store. The ethical and legal framework, we have the compliance with Uganda, the Uganda Public Data and Protection Act. Public Data Protection Act, all data are anonymized, informed consent for any personal data. So we have to receive consent forms to get data, especially having persons. Value mechanization, we have the creates a proprietary data set from Uganda, indoor environments, and also strengthening the AI performance and the competitive advantage. Now, the solutions and AI system description, we have here the core AI method, where we have the computer vision. Computer vision is employing the YOLOv8 for real-time object detection, and we are having the robotics, or you can call it the planning, mapping, and so on. That is using the simultaneous localization and mapping, SLAM, and we may be also having the graph algorithm, that is the ESTA, for optimizing the path planning. Also the input, output, we have the input where you have the camera, RGB-D, lighting detection and ranging, LiDAR, ultrasonic sensors. Now the outputs, we have navigation command, obviously, which will say turn left, turn right, stop, or move forward. That will be it. Now AI decision generation, sensor fusion, built an environment map, and the ESTA selects the safest path. YOLO detects dynamic objects, and the dynamic actually and the static objects. And now the model predictive controller adjusts movement in real time. Integration, we are going to run our system on a robot operating system, and sends motor commands, integrate with Flutter, our mobile app for user interface. And also responsible AI, we have the explainability, like the grid cam, the heat map, and how the obstacles are being avoided and controlled. The key metrics for the evaluation, we have the technical metrics where we have object detection accuracy, and we are expecting it to be more than 90%, as you saw that in the demo where we have detection being 98, 96, so it is over 90% in navigation. Latency, it will be less than 150 millisecond system uptime, which will be also at 99%, 99.5%. So it will be uptime in order to avoid accidents. We also have the user-centric metrics whereby we have user satisfaction, and we are targeting over like 5. The target is more than 4.5, and all the success rates, it is 99%. Obviously, it will be attained, and it has been there on simulation of what we have been on. Now the ethical metrics, the fairness, equal detection accuracy across pedestrians, demographic interpretation, and also sharp analysis for model decision. Now business metrics, we have customer acquisition cost, we have the low lifetime then also the high and long-term value investment, and also the significant cost saving on support staff. So have unfair advantage and the differentials where we have what can't others easily copy from our project. For sure there are many things, but mostly there are 3 core things. That's the priority data set, which are collected here in for Makerere University and the other health facilities. Actually, these datasets are collected, annotated, and stored, meaning they are confidential, and someone cannot just come and copy how it was, and also customize for Uganda. Also, the content-specific optimization, whereby our model are finely tuned for specific architectural layout and challenge of Ugandan institutions like universities and hospitals. And also the strategic partnership we are looking at, meaning our deep integration with Makerere University provides a real-world testing ground, and meaning it will be launched and patented as our group project. Now feedback loop, like every journey, the wheelchair takes, it generates more data, which is used again to continuously retain and improve our AI model, making the system smarter over time, meaning it will be accurate and more efficient. Have channels and distribution. The acquisition channel, the acquisition channel for funds, we shall see direct partnership with universities, disability centers, and the Uganda National Hospital, demographics, and so also at the Tech Disability Expo for assertive technology in Uganda. Also, delivery channels, we have the primary, whereby we have the physical wheelchair unit, secondary, and also the companion mobile app, which we are building in the Flutter. Also the partnership, where you have the Makerere University courses, and I expect the Ministry of Education and some NGOs like UNICEF. Now the retention tactics, we have the regular software update with new features. Obviously, we shall be upgrading our system over and over time, in that it will be updating as gadgets they're having. Now the revenue stream, we have the direct revenue stream, whereby you have the wheelchair as a service, and someone will have to subscribe either monthly or yearly for a wheelchair to use it. And also one-time licensing fee, whereby institutions that want own it and customize for their institution, they can buy as a whole and take. And also have some indirect revenues, whereby we can get some data as a service, like our anonymized mobility partner data for urban planning. Of course, with strict governance, will be there, but still we can get revenue from it. Now, also the custom deployment for customizing the system for specific institutions like schools and hospitals, or hospitals like from a certain ward to a certain ward, we can really customize and make the real map from them from within, in that it can just, you tap library, it takes you directly. Yeah. Now we also have the premium tiers, where we have the basic, we have the core navigation features, and also have the voice control, personalized route, and advanced analysis. All those are revenue streams. Now the key resources, we have the human resource, where we have the AI engineer, the data annotators, the mechatronic engineers, and the user interface designers. The technical infrastructure, we have the NVIDIA Jetson Nano. We are going to work with that one, and with the help of the GitHub and sometime the Google Colab. Also the data infrastructure, we have the local data storage server, and we have the custom data annotation tools like RoboFlow. We have the organization resources, where we have Makerere University, IP office, and legal advisors. The financial resource, have the seed grant from Makerere. We're expecting it, of course, and also seeking impact investments. Now the key activities have model life cycle, where we have continuous data collection for our system to be perfect and good. Also the mobile production development, we have the mobile app feature development and hardware robust testing. Also operation activities, meaning 24/7 system monitoring and maintenance for people to be safe. And also governance and compliance, meaning quarterly BAS audit, and also annual Public Data Protection Act compliance reviews. Customer focused activities, meaning it's user training workshops. We can also consider them, bring almost all users in the workshop when there is an update in a software, and also monthly feedback surveys to improve our system. And the key partners, we are saying the technology partners, we have the NVIDIA, the Jetson Nano developers, and also the robot operating system community. The data partners, obviously that is Makerere University, allowing us to take data and also mapping. Ethical oversight partner, obviously Makerere University Research Ethics Committee, and also the distribution partner, we have medical equipment supply in Uganda, and also other universities, or even the PPDA itself. The strategic collaborators, we expect UNICEF in Uganda, Ministry of Gender, Labor and Social Development. So now the cost structure, the data cost, we expect it to be 15%, meaning for the annotation and storage. Then the computer infrastructure, the Jetson Nano cloud and so on, 25. The human resource, this one will take the huge amount for salaries and salaries for this core team, the developers and the team operators. So compliance and legal to take like certifications and so on, to take 10%, and the marketing distribution this percent, and also maintenance and the scaling. So spare parts, retention, and the compute to take 5%. Governance, ethics, and compliance governance model. An internal ethic body comprising of engineers, disability rights advocates, and also the experts. Now fairness bias, we have to be using fair learn. We call it the fair learn, to ensure equal performance across all demographic users. And also transparency mechanism, say publicly available model card detailing the performance and limitations to avoid bias. Then explainability tools have integrated GrandCam for obstacle detection explainability, and legal framework have full compliance with Uganda's Public Data Protection Act. Now we have also the accountability. All critical incidences are logged and require a human interval in the loop. Scalability, sustainability, we have the scalability framework. So we have the microservice architecture on robot operating system, customized AI, and also continuous learning, where you have the pipeline for retraining model with a new anonymized trick data. Also localization, say designed for Ugandan English, the Ugandan English content, and also local buildings like in schools, hospitals, and so on. So it will be easier for it to be adopted in Uganda. Financial sustainability, revenue from wheelchair as a service subscription covers ongoing costs and research and development. Environmental responsibility, we have energy efficient Jetson hardware, solar charging. It can also be capable or embedded in it in order to make it really reliable in terms of power, and also resilience, where you have like redundancy server, these redundancy sensors, and system can perform safely. When a sensor maybe is damaged, it can really stop with an emergency. Or if a sensor is damaged, it can really continue with other sensors. Intellectual property and innovation. Our IP asset, we have the novel algorithm, our unique sensor fusion logic or low power device, and also proprietary data set. Annotated, this annotated Ugandan Indo, especially from Makerere University, and also software system, the integrated AI navigation stack, the full stack for it. And the protection strategy, we have the copyright, we have to do a patent for it, or copywriting our data software and the algorithm. So for our software code and dataset, so patenting, funding, and so on. So trade secret, our community evolve in trading methodology and so on. So there's nothing like stealing something from us. Now the team contributions have Kaira, Nathan, they are this one. So thank you.